Okay, question 20. The diagram below shows an angle theta graphed on the xy coordinate plane. Segment RT is the initial side of the angle. Segment RM is the terminal side. Segments RT and RM are the radii of the unit circle centered at origin r equals r, 0, 0. The x-coordinate of the point is, point M is negative 1/2. What is the measure of theta to the nearest thousandth of a radian? Well, there's a lot of approaches to this problem. There's a whole lot going on here, but this is a unit circle question. And ultimately, in a unit circle here, let me draw one out real quick. What you might want to realize is that this section right here is just slightly left of this degree, which is 270, because they count by 90s, right? This is 0, 90, 180, and that's 270, but it's a little bit less. And if you remember anything about unit circle, is they count like this. This is 30 degrees. The middle one's 45, because that only counts by 15. Then it goes another 15 to 60, and then you're at another 30 to 90. So it's like 30, 15, 15, 30, 30, 120, 15, 135. We'll go ahead and just count them. This one's 150, 180, and then 30 again. So 210, then 15, 225, plus another 15 is going to be 240 degrees. Now right there looks about 240 degrees. Now, do you remember the coordinate situation with unit circles? If not, that first coordinate is the square root of 3 over 2, comma 1/2. The middle one is square root of 2 over 2, comma the square root of 2 over 2. And then the one after that's the reverse of the square root of 3 over 2, 1/2. So it's going to be 1/2, and then square root of 3 over 2. So it's kind of like, if you look over here, this is the opposites of these. So it's going to have the negative 1/2, and it's going to be the negative square root of 3 over 2 because it's down here. So it says, what's the measure of the angle to the nearest thousandths of a radian? Radian. So it looks like that's 240 degrees. To convert to radian, we're going to multiply by pi over 180. Let's do that. 240 times, you can hit the pi button, or you can type pi over 180. And it looks like it's about 4.1887, right? So 4.189 would be the radian measure of that circle. Now, that's not the only way you can do it. One thing that I will point out gladly is that if it says the x-coordinate, remember in the unit circle, the cosine is always going to be, so the cosine of the angle is always going to be the x. And then the sine of the angle will always be the y. So if I know the x-coordinate is negative 1/2, what I want to do is I want to see, all right, which one of these radians is going to get me a value of negative 1/2. So if I do cosine of 4.712, cosine of 4.189, you get the idea. If you go down and you kind of pick your radians, one of those should get you a number that is approximately negative 1/2. Now remember, these are rounded, so they're not going to be exactly negative 1/2, but watch how I do that. So you make sure you hit the wrench and make sure you are in radians. So if you're in degrees, you gotta click over on radians to do this. And then you go through and you look at your answer trace. So COS, parentheses 4.712. That looks like it's really close to 0. So that's not going to work. COS 4.189. That's like negative 0.499. That's like negative 0.5, right? COS 3.927. That looks like the negative square root of 2 over 2. You might recognize 0.707, so that's actually that one. And then COS 3.665. That looks like the negative, or that looks like square root of 3 over 2. You recognize that decimal, right? Maybe, maybe not. Doesn't matter. The one that's closest to 1/2 is negative 1/2 is negative 0.499. So that's the closest number. So 4.199 is your radian angle measure in the cosine. So either way, you got a way to get the radian using memory of the unit circle or knowing that the x value is the is what you get when you plug in the angle in the cosine.